If you understand the design of C++ streaming input and output, then file handling is no great mystery. If you're familiar, and you should be at this point in your programming career, if you're familiar with how cin and cout handle input and output for you, then you really shouldn't have any difficulty understanding streaming file input and output, because it works almost exactly the same way. Remember that cin is a stream that points to your default input device, which for most of us is the keyboard, and cout points to your default display device, or your default output device, which is your display screen. So the nature of streaming input is such that whatever is typed in at the keyboard is put into a stream, and as it is asked for, or as we program cin statements to ask for integers, characters, text strings, whatever there may be, it picks up the next item that's in the input pipeline. The same way with cout. When we send various data items through the cout stream, it sends them one by one to the default display device. So if we keep that in mind and we begin to work with files, it's very easy to understand that as we open an input stream from a file, that is going to bring the data into our program from the file, and likewise if we open up an output stream, it's going to send whatever data we process to an output file. As we begin to work with files, I want you to keep 5 points in mind. There are 5 steps that you will need to do every time that you utilize a file, whether it's an input file or an output file, when you use one in your program. First step is you need to include the fstream header. Number 2 is you need to declare a data type of that file stream, whether it is an input stream or output stream. Number 3, you need to open the file that is going to produce data or receive data. Number 4, you process the data in whichever way your program requires. And excuse me. Number 5, you need to remember that you need to close all of your files. And by closing the files, that forces all of the stream pipelines to be flushed out to the output file, so to make sure there's no input or output left unprocessed. So if you understand the correlation between the streaming input and streaming output, whether it's the keyboard or a file, if you understand how those two are similar, it's going to be real easy to produce your first programs here. This is the text file in which we're going to do our experimenting today. As you can see, it's full of human readable characters, and in fact it's a bunch of words all put together here. What we don't see are the hidden characters in the file. At the end of each of these lines, I pressed the Enter key, and what that did was insert an ASCII 10 and an ASCII 13, or the carriage return line feed combination, so that a new line is started. Now our program can make use of that character. That will tell us when we have reached the end of each line. The other character that we don't see is down here after the double quotation, and that is we have an end of file marker. In the DOS system it is Control-Z. In other systems it may be something different, but regardless, C++ is going to look for that end of file marker, and it's going to set a flag, the end of file condition. As long as it has not reached that marker, then C++ will tell will recognize that the file has not been read completely. Once it reads that end of file condition, it will set that flag and report back to your program that it has reached the end of the file. That tells your program that there's no further text to be read within the file. So we're going to process this simple file in a couple of different ways, and we can come back to the file if necessary and verify that everything has been read, everything has been modified, whatever the case may be. This is a very simple program that demonstrates the 5 steps of file handling that I mentioned in the introduction. The first step is that we need to include the FStream file header, and what this does is it includes, just like IOStream, the input and output functions that allow us to read and write data to and from files. The second step is to declare an instance of the file stream. So in this case, we're going to be reading from an input file. And so I have created a file stream identifier called InFile, and it is of type IFStream. An output file would be OFStream. And so what that does is now I've created a place in which to connect the file to the program, and that's what I do in step 3. In step 3, 2 things happen. I associate the file stream, InFile, with a specific file, in this case the testfile.txt that we looked at earlier, and I open that file. Now when I go to open that file, it is going to go out to the operating system, ask for access to that file. The operating system will grant that access, and if the file exists and it's readable, then C++ will open the file, or will receive a pipeline to that file. If the file does not open, for example, it might not exist, it might be damaged, whatever the case may be, then the file will give us a status of bad, or the file stream will have a status of bad. So we're going to always check after we try to open a file to make sure that it opens successfully. So if InFile has a poor or an error status, then we want to kick out an error message and exit the program. We don't want to try to process a non-existent file stream. If the file opens successfully, then we skip down to here, and then this is where we perform whatever processing that it is we're going to perform. And finally, the 5th step is always to close the file. What closing the file does is twofold. Number one, it flushes all of the data out of the file stream conduit. And so everything that's in the conduit gets pushed out to the file, and it adds the end of file marker to that file. Now, you'll see in a lot of instances that this is proposed as kind of an optional step. It is not. You must close the files, because normally the operating system handles this. But if there is an error, your program crashes, for example, or the operating system has an issue, whatever's in that file stream, if it's not specifically flushed out, will be lost. And so you always want to make it a point to include the close command in your program. So let's come back now to the processing. In this case, it's very simple processing. What this while loop says is that while we don't receive the end of file state, so as long as the file reports that it still has data to be read, continue to loop over and over. In this case, we are going to read a word. Now you see that I use InFile in place of CIN. So InFile, the InFile stream, operates just the same as the CIN stream. Remember, CIN reads data from your default input device, which in most of our cases is the keyboard. And cout operates likewise as a pipeline to the default display device, which again for most of us is the screen. So in this case, I place the input file stream and I use the extraction operator to pick up a word. That's a variable of the string type, and so each word that's in the file is going to be picked up one by one. And in this case, I'm just going to output them out to the screen and add a new line after each one. So what we should see is a long list of all of the words that are in the file if this program operates successfully. So let's execute the program. And there we go. We see the output is one long list of all the words. We can come down to the bottom, make sure that the very last word is him with a quotation mark. And so our program has been successful in what we've asked it to do. Now, this is, although the example is simple, this is a good way for you to get started as you're working with files for the first time. Convince yourself that it's going to work by simply reading the file and then sending whatever you've read back out to the screen. Now, however you want to manipulate that in between is up to you, or what I would do is start by basically structuring your program in this fashion, and then just read the file, word by word, character by character, whatever you need to do, and then output that data out to the screen. That will tell you that at least your file handling is working the way you expect it. Now, once you've gotten the file handling working the way that you need it to, then you can go back in and add all of the manipulations or the processing that you need to include to meet the Now, I've modified the program a little bit to do some processing with the file. We still have all of the same steps, but what I've done is modify the processing loop. So as long as file's not end of file, then I'm going to perform all of this processing. And what I've done is generally when you're doing file handling, you're not going to just read the data and then spew it back out. You're going to read the data and do some action upon that data. Since this is a file full of words, I'm going to look for certain words and then perform a substitution. So for example, if the input word is the, lowercase the, then I'm going to change that word to uppercase the. Likewise, if I find the word and, I'm going to substitute the ampersand. And here on my cout statement, rather than showing these words in a list, I'm going to show them a little bit more in the same way that the file is being displayed. So if we go back and we take a quick look at our text file, we see on the right there and someplace else as the over here. So those should be, our expectation is that the data will be read and then converted. Likewise, we'll look for and. We find an and right here and an and right here. We should see ampersands in that place if our processing loop is working correctly. So let's go ahead and run this. And you can see that number one, our data is formatted a little bit differently on the screen. I took the end lines out after every word, and it is just streaming all the data out to the display device. But you can see that our processing worked. So as we read the file, we intercepted the word the. It was in the proper format. Our if statement was successful or evaluated to true, and we substituted in the word the. Likewise, it found the word and right here, so on the last and it substituted the ampersand there. We see the happened there and an ampersand over here, and I believe that's it throughout the whole file. So you can see that really file handling is very simple. It works a lot like CIN and COUT, and so if you understand those mechanisms, you shouldn't have any problem with file handling as well. So now the next step would be to write this modified data out to another file. So we're going to modify the code and then come back and execute it again. So I've modified the file once again, and this time I've added an output file stream. So I added a new identifier called outFile, and it is of type OF stream, so that is an output file stream. And then I've opened that file. Now what this has done is create a pipeline out to a new file. So the operating system has given me that handle, and whatever I stream out to that file should be written in that file in the format that I pass it. I've taken out some of the safety belts here to keep the code size down onto a single screen, but you need to make sure that all your files open successfully. All right, so we come back into our processing loop, do the same thing. If I find the, give it the. If I find and, put an ampersand there. And now, as you see, I've commented out the test line that we had before where we were simply streaming this out to the screen. And I did that because I want you to see that the out file stream works exactly the same way. So rather than directing my output to cout, I'm directing my output to the out file conduit. And so that pipeline is going to carry whatever I send it out to the modified text.txt. And then I come down here and I close both files. So I'm going to execute this. And wow, look at the excitement. All it does is give me the pause statement because I've sent nothing to the screen. And so I hit enter, and we can come over here and we can look at modified text. And as you can see, the was substituted, the ampersand was substituted, the and the other ampersand right there. And so I want you to have some confidence in your file handling. You have worked with cin and cout for some time now, and I think you've become old hands at this. Think of the input and output file streams in the same way. They operate generally the same way. There's a couple extra steps to using them, but it's nothing to be intimidated by. So good luck with this week's programs, and I look forward to seeing them. If you have any questions, don't hesitate to either leave a question in the questions forum or let me know via email.